Hello and welcome back to another coding session with Mr. Jacob. This one, I'm not even sure if I'm going to actually publish it to YouTube, but we will see. If you can see me now, I've decided on publishing it. What I want to do in this video with you is I want to take first a look at my refactorings I've done with the pixel loop game update render loop thingy that we created in the last video, and then I want to refactor it a little further for better use. First of all, let me see. I have done some things to this pixel loop here. We had in the last session two functions which created a simple loop, a render update loop with a fixed time step for the updates, and we had some sort of hackish tau / pixels crate integration to draw some things really on the screen. What I have done now is I have refactored things to have this loop in a more general way so that I can actually use it within the tau implement, the tau and pixels implementation, and without it, and maybe in the future with different other systems I might decide to incorporate. So what I have done is I have created a pixel loop structure here, which more or less has all the different variables that we need to accumulate and to store between the different loop cycles. So we have some struct in memory where we can store that stuff, like the time accumulator. If you are interested in what this one does, take a look at the last video. It essentially tracks how many time in real time has passed so that we can actually trigger the right amount of updates then. We have the current time and the last time to track the differences between the different frames we render. We have the time step of the update, which we want to actually enforce, the fixed time step there. We have some variable state, which you can see is just an arbitrary generic, so it can be anything. We have a surface, that one is new, I will talk about that in a second. And we have our update and render functions, which I've now just put a little bit outside of this to define it in a more well working manner here, which is here at the top, which simply take a state and a surface, or what's that? A state and a surface and a duration, how long the frame rendering took. So there hasn't changed much. I've introduced error handling by having all our different functions return results. And we have this tau event fn, which we will talk about in a second, which is used to handle window events, but that in a second. So now, actually, once this thing is created, we simply initialize all our variables, and then we have an implementation here called next loop. And essentially, next loop is is what we had before in our loop function. So I've just moved the stuff out of it, and I've moved it into this method of the struct, which has, of course, access to the struct data here using our self. And it updates all the information as before. It calls the update function, it calls the render function, it does everything as before, but it doesn't do it in a loop, but it can be called in a loop. And then we have our simple function here, which is run. It's a simple function in this module. I've actually put that into a pixel loop module, so to speak, so that it is not part of the main module. It's a preparation for the time when I want to maybe extract it as a library or stuff like that. And this run function here is more or less the loop that we had before. So I've just split it up. So you are giving the run function a state, you are giving it a surface, more on that in a second, you are giving it the update and the render function, and it's essentially creating the pixel loop for you, and then it is essentially running in a loop the next loop function over and over and over again. So that is what we had before. Now, I wasn't very sure at first how I would handle the transfer of information about our drawing context. So I was sure that I wanted to create some sort of abstraction layer for it so that we could implement render and draw functions for stuff, like example, something like draw me a rectangle or draw me a circle or a line or whatever, and put it somewhere where all our where all our render functions could actually reach that code. And I wanted to do it in a way that the pixel loop would run separately from this pixels crate and from tau, so that I could actually in the future, or if anybody else wants to use this code, decide to use something completely different to do that. Some other library, some other engine, some other system. And that is why I introduced the concept of surfaces, and we will work on that concept in a second. I'm not 100% sure if surface is the right name here, but I couldn't come up with a better one. So yeah, essentially at the moment we only have a pixel surface, and this pixel surface implements certain methods. It can be created with a pixels instance that actually comes from the pixels crate. We have a width, we have a height, and we can retrieve the frames as the current frame as a mutable U8 byte array. That is something that we are going to change in this video. And you can retrieve that and you can then manipulate it, and you have a function render which simply does the render step of our pixels function, which then kind of blitz all the pixels to the screen. And you can retrieve the pixels object itself, which are needed at some point. We will see, because we are going to refactor that. So that is the surface, and the surface is actually provided with each of our update and render functions. So each update and render function will always get a surface, which you can then use to draw, for example, something in it. Why in the update function as well? Because I'm not 100% sure that in the update function it might be needed to read the currently active pixels. And therefore I decided to put it in there as well. We might put read-only version of that in there just to enforce that nobody in the update function can actually render something to the surface, but yeah, we will see. And then I refactored all this tau stuff. I have a couple of small data structures here. We will talk about that in a second, but essentially what I have here is we have a run function that is the normal loop, and we have a run with tau and pixels function. And that actually takes a state as well. It takes a couple more things. It takes a context here, which is a tau context. Talk about that in a second. We have, oh, wait, tau. There we were. We have a surface, but in this case, as it is a function hard-coded for tau and pixels, we have a specific pixels surface here and not a generic surface. We have an update fn and a render fn as before, and we have a third function callback, which is the handle event callback, which has a different function type. I will talk about that in a second when we see an example of that. And essentially, I'm more or less doing the same here. I'm creating a pixel loop with all the given information. I'm then taking the tau event loop from the last one we talked about that, which actually is part of this tau context I created. The tau context essentially only transports the window and the event loop that is needed to create all that stuff for us in a neat little package. And we are taking this event loop, we are actually running it. We are then calling this handle event here. We will talk about that in a second. And then we are doing our event matching as before. And once we have all main events cleared, this was the one where we had our run and draw loop before. We are simply calling pixel loop next loop, and we are unwrapping that here because we can't do proper error handling in here, like returning it, because the run of the event loop kind of takes over the thread, and it has never returned from that. So yeah, that's a problem. I'm not 100% sure if there's a better way to do that, but yeah, if there at this point there is an error, we actually can't do very much but panic out of the application, and that is what we are actually doing here. And then I have introduced or reintroduced, better said, a simple event here which is needed to be able to close the window. So essentially this handles if the window is closed, so if the close of the window is requested by, for example, pressing the close button in the upper left corner, we will tell the application that we want to exit. So yeah, that is what is done via this control flow. And that is all the magic behind this new loop, which now uses the same pixel loop and pixel loop running system as the other loop, and it's not separate. So I've just done that. And then I've simply kind of refactored and a little bit generalized the initialization of the window, which now results in this tau context, which has the event loop and the window in the end. So we can here see that the tau context has the event loop and the window. And I have generalized a little the init pixels command, which creates this pixels context from us taking such a tau context and creating a proper pixels create context for this window surface. And yeah, then we actually have our game loop. And if I now take a look at the game loop I have here, let's see, it's actually not that, it's actually quite neat to use. So, sorry. We are simply creating such a tau window context here by telling it what title we want, what width, what height. We are actually initializing this pixel surface here. We are getting then back the pixel surface. And then we are just putting all of that run with tau and pixels, the state, the context, the surface into that. We have our update function here. We have our render function here, which at the moment simply clears the screen and renders a black screen. And we have still our code, which kind of determines the FPS for updates and renders. And we have something new here, and that is actually this where is it? This handle event function here, which we call first before handling anything in the event loop, and we are simply giving it references to all the other different or to all the stuff here. It gets a state, it gets a surface, it gets events, and it can then actually do this event loop stuff outside in our game logic or in our application logic and do something. Like, for example, here in this quite nested match event stuff, I will need to think about how I can create a better abstraction for this. But at this moment, it simply checks if the left mouse button pressed and sets a variable in our state to true or false, and it tracks the cursor, so the mouse position while it is moving, and sets a corresponding position in our state as well. And there is a neat function I found out about which we can use. It's called window pos to pixel pos, which actually can calculate from the window position of our mouse the position in our pixel grid. So that's actually quite nice, because the window resolution might be higher than the actual pixel resolution, because we can actually either create it this way, that is something that I want to make configurable in a second, or it might actually be this way if the monitor, for example, or your system is some sort of high DPI system which has a very high resolution, like for example Macintosh's, then they are actually rendering at a certain multiplication. For example, the laptop I have in front of me always renders everything in 2x, so it renders everything with, like, every single pixel is rendered as 4 pixels. So the surface actually is kind of smaller. So if we request, let's say, a 320 by 240 image, then we actually get in real render dimensions, we get 640 by 480. And yeah, that is actually my refactoring so far. So what I want to do now, or my main reason for starting this, is I wanted to make the surface a little bit more generalized. So first of all, you can see that this still runs. I've just removed actually the render code, but only left the code in there that makes the background black. So we only have a black background here, but as you can see, I can still compile it, I can run it, I can now close the window and it exits. which is quite quite nice. And what I actually want to do is I decided on making this a little bit more generic. So I thought I could implement a trait called surface, and then I would decide on what actually is in this thing. So what I thought about was I first of all take all of this stuff and put it in there, and new will not be in there. We won't need any of this. So let me quickly remove that. Come on, that didn't work as I wanted it. We don't need any of the code. We only need the function signatures for now. So let's see. And we don't actually want that. So we definitely need a way to retrieve the width, and we definitely need a way to retrieve the height of the surface. I don't think I want to actually allow it to retrieve the frame as a byte array. Let's see. We definitely need something like render. I'm not 100% sure it should be called render. Maybe we should call it blit or something like that, because we are actually blitting the surface to the screen, or we could call it swap for frame buffer swap, or I think I like blit. And yeah, pixels is very specific, so it won't be in the trait as well. So if we can't access actually the pixels as byte array there, which I'm not 100% sure I want to do, maybe in a little bit other way. But what I want is I want to need a way to access those. So maybe we can start with something like we add a get function here and do something like self. And it would be an X, which would be a U32, and a Y, which would be a U32. And it would result in, yeah, in what would it actually result? I guess we might give a color or something like that. And let's implement a simple struct called color, which makes things a little bit easier for us. Like we have an R, which is a U8, a G, which is a U8, and a B, which is a U8, and maybe we then can in the future implement a lot of different from implementations and stuff like that, which would allow us to actually create such a color from, for example, a hexadecimal or something like that. Okay, so furthermore, we want a set self.x U32. Oh no, this of course needs a mutable self then, mutable self. X, Y, U32, yeah, and we need a color, I guess. So the color we want to set. And does it return anything? I don't think it will return anything. And the further I'm thinking about this, I'm not sure, I'm not 100% sure that I want to actually take U32s here. Maybe I want to take I sizes or I64s here. Because then I could actually do the inbounds check. But maybe we can do this in another way. We need something like inbounds, definitely. So what we want to do is we want to know if a certain coordinate is within the bounds of the surface. And I guess we could take different variations here, like so this needs self, but maybe we can simply do something like it takes an I size, which would be reasonable, I guess, and Y, which is an I size as well, and it returns either, it might do something like it does not return bool, it returns an option with maybe a U32, so it either returns a none, then it isn't in bounds. But if it returns something, it could return the value mapped into the bounds. That would actually be quite nice, I think. And there is something wrong? Yeah, there is something wrong. Okay, so we may want to implement in the future something like the ability to set a certain range of colors / pixels. That would actually be quite nice. But for now, let's see if we can do it this way. So let's restructure our pixel surface to do that. So first of all, pixel surface. What we want to do here is we want to impl surface for pixel surface. And yeah, now of course we don't need those anymore, and this we don't need at all. This is now called blit, and we don't need the pub. This isn't there anymore as well. So, and there are missing members like get, set, and inbounds. Yeah, okay, that makes sense. So let's quickly maybe implement get. So get would be actually something like, the question is, what happens with a get if the get is not in bounds? Do we actually crash there? Should this always be a result? Maybe we should maybe put this into a result, shouldn't we? So we want something like result color. And the set actually should return a result with an empty tuple as well, so that we can simply say, okay, we want a result here, and set returns result empty as well. So yeah, let's implement get. So if we can actually do this with we can actually call our self if sum x dot y or let's just do if self dot inbounds inbounds xy is none. We want to do something like we want to return an error, and it should be an anyhow. And we need to, of course, import that then. Anyhow, there we are. Can't set pixel x cross y to as it is out of bounds. And then we might want to put the something like width times height there. And yeah, I guess that this is now, you might have meant refer to method itself. Cannot find. Yeah, that is actually quite fine, because what I want to do there is I want to say width equals self dot width and height equals self dot height. Something like that, I guess. Okay, so that is actually a neat little error we can put here as well. Can't, oh, this should have been can't get pixel as it is out of bounds. And otherwise we will we will return the color, I guess. So we will take the let I equals y times width plus x and times 4. Oh, that's actually an interesting question. Should we? I guess we should put the alpha channel into the color. Where is our color struct? There's our color struct. So let's put the alpha channel in there as well, and let's see. Color. R is then, we need something like let self dot pixels dot frame, which would be the buffer, I guess. And then I should be able to do something like buff I plus 0 for the first one. And the 0 is, I was asked why I always put those zeros there, and usually they are optimized. They are removed by Clippy at some point, but I actually like putting the zeros there just for the symmetry. So I see, okay, the first one is the index directly, then one to the right, one to the, and so on and so on. So RGB A, so this should actually be our color. And this it does not like, because why? Because width, we don't have the width here. Yeah, that's correct. So self dot width. Yeah, something like that, I guess. Okay, so this should actually be our get method. And I think we can take most of that and put it into our some set method, but we don't need that. We want frame mut now, and it is a mutable buffer then, I guess. I'm not even sure if I need to specify that. We will see. We will see. So at the end, I'm returning the empty set, and what I'm doing here now is I'm taking actually buff I plus 0, and I'm setting it to color.r. So we are actually doing exactly the opposite of what we had done before. So this was the alpha channel. This is the blue channel, this is the green channel. So yeah, as it is a mutable reference, I don't need a mutable reference. It says unknown. Maybe there's something else broken, and there's a lot of different things broken, I guess. But yeah. So what it's now missing here, struct with similar name exists, pixel. Yeah, I should have used the right name, and now everything gets read. Okay, so let's see. Self inbounds. Argument to this method are incorrect. Expected I size found U32. Maybe we should actually I need to figure something out. Can I do? Okay, let me first implement this method here. So let me implement this method. If x is less than 0, or x is bigger or equal to self.width, or y is smaller than 0, or y is bigger or equal self.height. Then I want none. And otherwise I want some, and I want x as U32, y as U32. And I guess I want this to be an I64 actually. And then this needs to be converted to as I64. And this also. Yeah, I guess this makes kind of sense. I would like to actually handle this in a little bit more generic way. I have no idea if this changed the parameter type to match the trait eye size. Oh, yeah, because I now have in the trait I defined, where is it? There. So yeah, but I want I64 so that I don't have problems with the conversion. A U32 always can fit in an I64. So now let's see. Argument to this method are incorrect. Yeah, because... But this isn't a problem, actually. I can always do that. So what's the problem here? Mismatch type, expected unit type. Expected this to be unit? Why? Wait, what? Result color show. So I should actually be able to return. Give me the full compiler output. Expected unit type, found result. Why would it respect... Consider using semicolon here. Why would it expect it to be a unit type? I don't understand that. It should actually expect it to be a result? Oh, is this not... Didn't I... Yes, I did. Okay, wait a second. Why is it... That doesn't seem right to me. Consider using a Why would I use a semicolon there? I want to return it. Can I do something, or do I need something like... Wait, what? Okay, I don't really understand that, but yeah, I don't care if it works. So U8 cannot be indexed by U32. I see. That is actually kind of a little bit... yeah, okay, so we need to do something like as U size here. Okay, so this will be the same problem, even though I have not a real idea why. Maybe if you understand why this return is actually needed here, please maybe tell me in the comments. I would be interested. So as I64, and we will do the same thing here with the U size as U size. And now a lot of other things should actually be broken. So what is broken here? It was the... that was why I actually exposed the pixels on the surface, because I needed this window position to pixel position. So what is actually this? This window position is a F32. Maybe we should introduce something like that the surface needs to support something like this conversion, because yeah, why not? We can actually create something like that. So window position, or let's call it a little bit different. Let's call it physical position to surface position, and let's do physical pos to surface pos, and it takes an X which was an F32. Let's take an F64 for good measure, just in case other systems are giving us other floating points, and it returns yeah, what does it return? I think the real implementation returns a result, which either gives you the... I guess I want it to return an option which gives you the real coordinate as a U32. Yeah, I think so. And so this should this, and this should be this. And let's quickly implement that. So fn physical, yeah, there you are. Thanks for completing that. And what I actually need to do, what I of course, as always, forgot is the reference to self here. I will fix that in the trait in any second. So self pixels, what was it called? Window pos to pixel pos. So we take the it takes the x as f32 and the y as f32. And yes, we might lose precision there, but at this moment we don't really care. So, and I guess it was something like if okay, yeah, if okay u size. X comma y equals that. What happened there with all those? Wait a second, what? It's always those were actually okay. So then we want to return some x comma y, but I want them as what does it return? It returns a u size or something like that. Yeah, I think so, as u32. So now where's the problem? Expected option found. Indeed. Otherwise, I want none. So else none. Still not works. Expected bool found. Don't get it. What the hell? So consider. Oh yeah, there's a let missing. Indeed, there is a let missing. So what's the problem now? The problem is, yeah, self-declaration and so on and so on. I don't care. Expected comma, but there is a comma. Okay, let's fix this in the trait real quick so that it shuts up about that self. And let's go back to the problem there. And now it has, so self pixels, window pos to pixel pos. It takes a physical position, which actually is an f32 tuple, and returns this result. And now it's because I have a colon there. Why did I do that? So now it looks better. Yes, it does. Okay, so now we have this, so we can replace it actually. So let's do that, surface, and we now can give it the physical, let's delete that, physical, shouldn't it actually know how, wait, didn't I make this public or something? But the trait methods are always physical pos to surface pos. It should actually know that it can call it. Okay, physical pos to surface pos, and it takes position.x. Wait, we have position.x, position.y, and let me see, and we don't need this anymore, and it doesn't know this function. No method named physical pos to surface was found. Unmutable reference pixel surface. Oh, because we are actually not importing the wrong method. We are not the wrong file. We are not importing use pixel loop. And how did we call it? Surface. We need to import the trait. So otherwise it doesn't know. physical, there we are. So is this now okay for it? Interesting. That is strange. Pixels surface, but pixel surface implements exactly that now. Wait, what? Wait. I guess I didn't make this trait public. Yeah. Okay, so, and what we actually want is, we want, yeah, I guess we want something like unwrap, or, yeah, in this case we want unwrap or, but we will change, I guess, this implementation later on to allow for the cursor position to be not there. So now the cursor position is exactly needs to be a U32. So we need to change actually this one here to a U32, and then let's see what is the next compile error. Yeah, it is actually that we can't now render this. So what we actually want is, we want to remove that, and what we want to do here is do something like, I guess we simply want to do something like surface set xy color R0 G0 B0 alpha 255, and we want to handle the error, and this does not work. Why doesn't it work? Okay, I've imported the wrong color, I guess. Yeah, I did. So let's import the right one. So now this is okay. So this is now blit. Color is private. Yeah, I guess we can change that easily. So let's do that. And let's see, what is our next error? Field is private. Do we want to make those? Yeah, I guess for now we just make them public. It's a simple data structure. I don't want to create a new function and stuff like that now for it. So does this actually now compile and run? Okay, this actually looks good. However, the rendering is horribly slow now. That is interesting. That is really interesting. We made it a lot slower. I mean, there are a lot of function calls now, but I would have assumed that this one would optimize them kind of away, I guess. So maybe we could do something like, we could give it a hint to, for example, inline this thing here. Maybe this would make things faster. Not really. That's interesting. Why is it so much slower now? Let's quickly stash our changes and let's see if it really was faster before. It was a lot faster before. Okay. So why is it that much slower? I mean, of course, I'm not building it in release mode, so it's not doing a lot of optimizations there. But let me check. Is it this inbounds check we are doing all the time? Maybe is it the function call itself, or is it? Okay, that makes things already a lot faster, but not as fast as I would have hoped. Yeah. I mean, of course, accessing an array directly should be a lot faster than running these functions, but I wouldn't have thought that it is that much slower. I mean, if I actually build it with optimizations like in release mode, it should actually be maxing out again. Yeah, otherwise it would have been quite strange because I guess it will optimize away most of the function calls, but that's still something that I think is a little bit strange. So I'm not 100% sure that we want to go this route then. I'm not even 100% sure. Get the mutable byte slice for the pixel buffer. Yeah, I guess, but I guess this only returns a reference. I hope that this will not. Can I actually take a look at? Yeah, okay. So it only returns internally a reference to the pixels buffer, which is already there. Okay, that makes sense. I hope that, because otherwise it would be quite an intense operation maybe if it created that pixel buffer every time or something like that. Yeah, okay, I guess we will live with that for the moment. So what I now want to do is I have those surfaces here. So surface, which is now, I guess, that's not good. Let's Yeah, the problem here is that I now have a trait called surface and I have those generic types which are called surface. So maybe surface isn't the optimal trait name here. Maybe I want to call it something else, or I want to call the trait name something else, but the generic name, but I like the generic name, so maybe something like drawing surface or something like that. Yeah, I guess I will call it simply drawing surface for now. And but what I want to do now here is actually I want to ensure that the surface here actually is a drawing surface. And I want to do the same here, and it always tells me, it also already tells me that this is not possible. Bounds on generic parameters are not enforced in type aliases. I see. Okay, that kind of makes sense, I guess. So let's enforce it on the thing that actually uses that, and that would be the pixel loop. So I want that the surface is a drawing surface now. And I guess I need to tell here then the same, where surface is a drawing surface. Yeah, I guess that should actually work then. And does it produce any compile errors? Pixel loop. The trait bound surface drawing surface is not satisfied. The trait drawing surface is not implemented for surface. Wait, what? Oh, yeah, because I've not specified that this surface here is actually a drawing surface. There we go. And yeah, and I guess now we can do something. Is it still building? Because now we can do what I actually wanted to do, why I did this refactoring. Yeah, nice, okay. Yeah, and it is a lot slower, and I will need to take a look at that. Maybe we can implement some stuff. What I now wanted to do is I wanted to have a place where I can implement generalized drawing functionality. And what I can now do is I can implement into this trait, into this drawing surface trait, stuff that uses those specific implementation methods here to to draw stuff. For example, we could now implement something like clear screen, and clear screen only takes a color, and yeah, I guess most likely it returns a result because all of those functions need to return some sort of result now. And I guess then we are simply doing something like for y in 0 to self. Oh, it takes a self of a mutable self, of course, as well. So self dot height for x in self dot width, self dot set xy color. And of course this does not work. Why doesn't it work? Expected enum result. Okay, so yeah, what I want to do is I want to return an OK here. So, and I want to make a question mark here. And then it doesn't like the color. Why doesn't it like the color? Use of moved value color. Moved here because in previous iteration of... I see. I guess indeed we only want a reference to a color here because... yeah. I mean, we could always yeah. I mean, we could always dereference it because it is something that can easily be copied. But now, yeah, I need to do something like that here. And I should then give this out as a reference. And but does this make sense for, I guess for the getting part, it really doesn't make sense as we aren't storing these colors anywhere specifically. We are actually, yeah, I guess this makes a lot more sense. Okay, so now we have something like clear screen, clear screen, yeah, and now we could implement something else, like for example fn rect or mute, let's call it filled rect maybe, mute, and what do we take? We take x u32, y u32, we take a width u32 and a height u32. Nice. And mutable self, of course. And now we can implement that. So for y in y to height, for x in x to width, we want self.set x.y. Oh, so let's call that sx and sy for start, for start and end. And yeah, we want to do something like sy plus height and sx plus width here, and we want to set x and y with the given color, which I think I don't even have in the signature yet. So we need a color here, of course, a color reference to be precise. And then we don't need to specifically reference that there, and we should what did I do? How did I jump up there? And we should return a result. Yeah, and then do something like really return that result here. And I guess now we should be able to draw a rectangle. So let's see. Yeah, we broke this, of course, but we can now remove that and tell the system to simply do a surface clear screen with the color. Maybe we clear with the color red now, just for why not. So RGBA, and let's do something like serve, and let's put a question mark there, and let's do a rectangle here as well, which would be, I guess, maybe 40, 40, and it should be 100, 100 wide, and we want the color R255, G0, B255, A255, which should actually be yellow. And it doesn't like my rect call here. Why not? No method rect found for mutable reference pixel surface. Why not? Wait a second. Filled rect. I called the method filled rect. Yeah, makes sense. Filled rect. So, and this needs actually a reference to the color. Actually, why doesn't this take a reference to the color? I guess I want it to take a reference to the... I guess I want all those functions to only take a reference to a color. It doesn't make sense that they really need them as a copy. We might store more information later on in a color, maybe. Let's see. So this should actually be... Yeah, it should actually run. It's horribly slow, and it isn't yellow but magenta, but yeah, it does what it should do. So... didn't we have all those nice little information here, like, yeah, box position, box direction, and so on? And I guess I've removed all that code. Yeah, should we reintroduce it maybe? Yeah, maybe not, because I will do a lot of neater things with that in the future. So let's do a release run here, and let's see. Yeah, it actually can handle the 60 frames perfectly. What I would love to know is how much it can handle now as a maximum with regards to the rendering as compared to before. But yeah, maybe we can... Yeah, I was thinking about maybe implementing a way to do some operations like setting and getting a range of values, just to do something more quick here. Yeah, I guess we can do that actually. Why not actually? So let's do something like, for example, first, I guess setting is a lot more needed than getting. So let's do something like set range. And yeah, I'm not sure actually. Maybe I won't do that in the video because I first need to figure out the typings for that. But I guess I will do that off screen because it will involve some reading in the Rust documentation and stuff like that, and that's not very interesting for you. But yeah, for now we have refactored stuff a little to have now a way to implement generic drawing functions as well, which we might need or will need in the future. And I guess I will leave it at that. And yeah, I think this video might be interesting for some of you, so I guess I will release it. So I hope you had fun seeing me doing this little refactoring and explaining what I have changed. And the next video then will be something where we actually use this engine to draw something. And it has to do with something that flows down and can move and stuff like that. And yeah, I'm looking already forward to implementing that, which I found in a January, so Gen with a G, January competition from 2020, I guess there it was. And I just thought it's a great idea to implement that, and we will see what it actually is that I'm talking about. and then we will implement it, and then we will work with it a little and do some fun stuff with it. So yeah, I'm already looking forward to seeing you in the next one. I hope you had fun, and have a great day. Bye.